right, let's give everyone just a few moments to drop on in. Got to be able to hold off all the ravenous hordes for learning all this tech art wisdom. All right. Hope everyone is doing good today. Can you believe it? Today is the first day of October. Unbelievable. Where has the time gone? Tempus fugit, my man. Tempus fugit. I do not know. All right, so let's get this show on the road. Greetings, tech artists from around the world. It is 12:30. It is Friday, and it is time for Tech Art Talk Live. My name is Chris, and I will be your host for today's session. Now, for the last few weeks, we've been going on all about shader programming and all about diving into that which is HLSL, which is the shader. Now, as opposed to GLSL, HLSL, they're pretty much the exact same thing. So I feel pretty confident in teaching HLSL, knowing that if you wanted to transcribe this to GLSL, you could do so with very little effort. In fact, I often found that that was to be a very, very worthwhile exercise, is to translate HLSL to GLSL or vice versa. It's a very, very good exercise, and I would encourage any burgeoning shader programmer to investigate into that exercise because it's really well worth your time. All right, so let's get things going. Now, we started off last week as a little bit of an introduction into visual effects as we started getting into some of the fading and the blending and so forth. Now we're going to go full hog whore into visual effects, and we're going to start working with, post-processing, and in most specifically, we're going to be dealing with matrix operators. Now, what that all means is I'll have to get to that later, but actually want to get to it right now. So let's get this demonstration going. Whoops, there you see me. Ha ha ha. Okay, so let's get this show on the road. Okay, so what I mean by post-processing is that is any operation that's done to the rendered image after the rendering pipeline. So that means we're not actually operating and performing these shader activities on the rendered image. Actually, during the rendering itself. That rendering has happened in the past. Now, what we're doing is we're going to take that rendered image, then we're going to apply our shading operations to it, and then we're going to create some very magical things. Okay, so ultimately, what we're doing is the image goes from the rendering engine, and we're going to intercept it. We're going to take that image and we're going to do some nutty stuff to it, and then we're going to change it around, going to put some visual effects on it, and then send it back into the frame buffer so it will get displayed to the display buffer. In other words, let's see if we can run this up. It all has to do with the concept of render targets. Okay, so what we've looked up to this point is when we render from the rendering engine, we're just rendering to the back buffer. Now, the back buffer is this two-faced buffer of memory that's constantly swapping back and forth to the display. And so as one display is being written to, the other being is displayed to the display device, and vice versa. As soon as that finishes, then it swaps again. And so back and forth. That is the back buffer. But we're going to do something a little bit different from that. We're going to render, instead of to the back buffer, we're going to render to something called a render target. And what we're going to do with that render target is that we're going to take that render target and then we're going to apply it to a quad that's the exact same size as our display device. Yeah, that's right. We're going to actually retexture it again and put the texture on that, and we're going to send it to the render pipeline again. But then this render pipeline is going to have our post process on it, and that's where our HLSL is going to come in, folks. We're going to reprogram that shader in order to take that render target that's now sitting on top of our full screen scribe. We're going to render that new rectangle with our fancy HLSL, and then we're going to send it to the back buffer, and then we're going to send it to display. Now, we don't have to send it to the back buffer precisely. We could send it to another render target, and then another post-process, and so forth. So it really depends on what the visual effect is, but for this general purpose for instruction, we're just going to keep it nice and simple. Okay, so what is the full screen quad? Well, actually, a full screen quad is exactly what it sounds like. It's just two rectangles that are sitting on top of each other. There it is, gang. Pretty anticlimactic, isn't it? But that's okay, because we're going to be rendering to our render target, and we're going to render target and our quad geometry are going to be the exact same size. So there is a pixel to texel 1-to-1 ratio, so that when we re-render this quad with that target as the texture for it, then that means that we are going to be manipulating the image in a resolution that is perfect for our display. Okay, so there are ultimately, this week, next week, and the week after, we're going to be going over 3 different types of visual effects post-processes. This week, we're going to be going over matrix operators. And that means that we are going to take each pixel, and then we're going to multiply that pixel by a constant matrix. Next week, we're going to be doing a convolution or a kernel operator, which is kind of a little bit like a matrix operator, except that we're going to look at one pixel at a time, and then we're going to look at all the neighbors around that one pixel, and then we're going to use the neighbors' values in order to calculate the current value. And then during our third week, we're going to go into functional operations or operators, and that can be just about any old kind of fancy function that we can throw inside of HLSL. And we're going to get things like edge line detection, and then faux shading with halftones and so forth. But we're going to get that as kind, but we're going to focus just on matrix operators today. So let's go on and we're going to be worrying about 3 types of visual effects. Now you might say, matrix operators, I've never heard of them before. Well, that's not necessarily true. If you go into Photoshop and you start playing with the color values, and you start playing with the contrast, and you start playing with the hue, the saturation, and the value, you're playing with the matrix operators. If you go into your game engine, and the game engine has little global adjustments that you can do to a post-process where you bring up the color values up and down, and you can bring up the contrast back and forth. What we're doing is matrix operations. And so to keep it simple, I'm going to go through 3 demonstrations of simple matrix operations. We're going to be dealing with grayscale, which is kind of making things black and white. Sepia, which is kind of like black and white, but old-fashioned style. It's going to look kind of reddish brown instead of black and white. And then we're going to do it with color inverse. And then what we're going to do is we're going to bring all 3 of those together again to something generic, and that something generic is our matrix operator, and you see how these things actually evolve. All right, so what we're going to do is we're going to go over into our shader tool and kind of get things going. But let's get going on and display what our grayscale is going to be about. Now, when you create a grayscale, you just can't take the average value of all of your pixels, your red, your green, and the blue values, because your eye doesn't perceive red, green, and blue at the same way. It varies along. What's the most perceptive color in the eye palette? It's green, but your eye is really drawn to red. And blue, it's almost non-existent. And so, in fact, did you know that the Greeks couldn't even see blue? Yeah, that's right. So what we're going to do is, instead of just getting the average values, the red, green, and blue of every pixel, what we're going to do is we're going to multiply each of those channel values by a specific constant. We're going to multiply red by 0.299, we're going to multiply green by 0.587, and we're going to multiply blue by 0.114. Notice that when you add all these up, this adds to 1, and so that's how we're going to be divvying that up, and then we're going to be divvying that up by 3, and that's going to give us our black and white values. All right, so let's go and get our going on. Okay, that's what we're going to be seeing soon, but I want my, yeah, that's it, shader tool. Yeah, there we go. All right, now I'm going to be using the background image that we used a couple weeks ago when we were creating our sky cube maps. And so the reason for that is because, remember, we are not rendering directly from the normal rendering pipeline. We're doing this as a post process. So we're going to create a new thing, and just to show you that this is happening in real time, we're going to take a real rendered image, that we can still maneuver it and manipulate, And so this is going to be our background image. And what we're going to do is we're going to take this and create a post process out of it. So I'm going to right click on here and I'm going to grab myself a new effect. And we're going to call this Post VFX Demo. Okay, there we go. And believe it or not, folks, these post-process shaders, they're super duper simple. Why? It's because we're not actually rendering anything. We're just doing math on this stuff. So it's really, really cool. So it's really, really simple. And so what I'm going to do is take the first thing, we're going to get our resources. And we're not going to be bringing in anything fancy. Let me see if I can make this bigger. Come on, let's get some big time for me. Are we going to get bigger? Ooh, we made that smaller. Oh, there we go. It's a little bit bigger. But what we're going to do is we're going to create a texture 2D, and this is our render target. Remember how we said a render target is something that is other than the back buffer? That's right. And so here's our sampler state. This is just the normal trilinear sampler state where our filter is the min, the magnification, and the mipping. It's going to all be linear. And our addressing for both the U direction and the V direction are going to be wrap mode. And now we need our data structures. Now our data structures are going to be super duper simple because our vertex shader is almost non-existent, gang. We have very little to do about it. So with the input, all we need is the object position and the texture coordinates. So guess what? The object position is like almost non-existent because it's sitting at the origin, and our render quad, remember, is the exact same size as our display. And so the object position is going to always be 0, 0. But we got to bring it in just for dotting our I's and crossing our T's. But we are going to be working on our texture coordinates, and that's going to be real simple. So therefore, our vertex shader input is going to be basically the same as our vertex shader output, and they're going to be all the same. So with that said, let's go and take a look at our vertex shader. Okay, let me get a little bit of room here. Okay, like I said before, our post-process vertex shader is going to take our object in, and the object is just a full screen quad, and the full screen quad is sitting right on top of our screen. And so we're not going to have to worry about it moving around its position. It's at 0, 0, so we're just going to pass that right on through. The out position equals the in position. And likewise, our in texture coordinates, our out texture coordinate is going to be exactly the same as our in texture coordinate. Now that will change pixel per pixel, of course, but otherwise we're not doing anything different to that in vertex shader. Now you might want to say, hey, wait a second. Isn't the purpose of the vertex shader is to transform our object into world view projection space? Well, guess what, gang? It already is in world view projection space, and that's because our rectangle is the exact same size as our display. It's already been crunched. It's already been, it's already in world view projection space just by being the full screen quad. That's all we need. And so therefore, no, we don't have to do any of that. It's all done for us already. Okay, so let's take a look at our pixel shader, because this is where the magic is going to happen. All right, so here I just created a little vector here. And this is my grayscale intensity. I call it 0.299, 0.587, 0.114. Okay, now remember that middle value, that green value, is 0.587, and this is going to be the largest value because your eye is most sensitive to green, and it's going to be pulling in most of the green information. So all we're going to do is step one. We're going to get our information from our render target. So therefore, we're just going to grab that pre-rendered image, sitting in our render target. We're just going to say, okay, grab it. This is the color I'm going to work with. And then let's look at this, folks. All I'm going to do is going to take the dot product of my background color versus my grayscale intensity. And then I'm just going to pass it on the output. I'm just going to take the red value, the green value, and the blue value. That's what this intensity .rrr means, meaning that for the red, that's all we're going to need. Now you're going to say, whoa, wait a second. We're only going to take the red channel? Now we could put the green, the blue, and and the red, the green, and the blue channel there, but it really doesn't matter because once we get down to it, all we need is it's a grayscale image, and then all we need is just the red channel. That's all we have. Okay, so the last thing I want to do is put together a technique so that we know that this is a grayscale operation. All right, cool. So we have our post visual effects shader here, and so I'm going to grab my content, and so let's grab a quad. Look at this, folks. Quad. That just says, okay, whatever the display is, that's a quad. Okay, and now I need my draw state. There we go. There's my draw state. I'm going to move this over just a tiny tad. Give me some room. And I'm going to close that up again. And so I'm going to put my shader right into there. There's my quad. And now we see the render target. So we need the render target. So we're going to need the target coming out of our prior render. So I'm just going to grab this and put this into our render target. And so now I need a new render target to actually display what our contents are. So I'm going to go grab here is a scene, and we're going to grab a new render target. And voila. There we go. There it is. You can see that our scene is now in grayscale. It is now just black and white. And just to show you that this is live, let me go ahead and grab my world space rotations. I'm going to go ahead and grab this over here and move this back over here. Now notice that when I maneuver the world around, it's being manipulated all the same in my regular render pipeline, and then we're going to send it through another render pipeline where we're going to render just the quad with our render target as our texture image, and we're going to translate it into black and white. All right, so that is that is basically in a nutshell how it's done. And you see, it's not a very complicated shader. It's actually pretty simple. And guess what? This next shader, what we're going to do, we're going to do the color inverse. The color inverse is even easier, gang. Okay, now if we take the color inverse, all we have to do is take this color that's coming in from our render target, and we have to subtract it from 1. And you say, that's all we got to do? Yep, that's all we got to do, and that's all that there is to it. Okay, so let's go back to our shader tool, and let's implement this. So I'm going to just go ahead and pop open my shader. Now let's see, we don't need a new vertex shader because we're going to use the exact same vertex shader before. And let's see, I forgot to create this, so let me go ahead and create Control C. And we have here this. Okay, and so now all we have to do is we don't even need this intensity anymore, so I'm going to get rid of this. And so let's just keep things simple. Let's see. Let's see. So let's create a new intensity here. So I'm going to say like float 3. I'm going to call it intensity. Intensity equals, oops, don't want that to be there. Intensity, we want that to equal to a float 3. And inside of our float 3, we want 1 minus color dot red, 1 minus color dot G, and 1 minus color dot B. Well, folks, that's really all that there is. There's not a whole lot to it. I'm going to go ahead and get rid of these little suffixes here, and that's all that there really is to it. And so what we do need is a new pixel shader. Oh, okay. So that I made this a little bit more complicated, and so there I didn't need this grayscale value. Oops. I didn't need this value here. I'm going to get rid of that. And therefore, I'm just going to keep it simple. And let's check this out. We didn't even need to do all this. You know, it's even more simple than this. So I'm going to get rid of this. And I'm just going to say 1 minus color. 1.0 minus color.rgb. And that's all we are, folks. That's all we're going to look at. And so we're going to take a look at that, but we do have to create a new technique for this. So I'm going to add a new technique here. And there is our inverse filter. Okay, grayscale pixel value of line 43. Uh-oh. Grayscale, I'm going to call this should be the inverse. Oops. All right, there we go. All right, so remember, we're going to look at this, and then we're going to change our technique from grayscale over to inverse. Lo and behold, we have instant X-ray mode, folks. Okay, that was I think that has got to be the world's easiest visual effect of all time. And there is just nothing easier than that. And so that's one of the advantages. So, you know, take advantage of it where you can. So all you have to do is subtract that color away from subtract that color away from one, and then you've got an instant visual effect on your hand. Okay, the last one I wanted to go over was the sepia tone. And now remember, the sepia tone is kind of like a black and white image, but it makes it look old-fashioned. So it's going to look kind of reddish brown. And that reddish brown is called sepia. And so for that, we're going to actually, instead of just one formula where we have a different red, green, and blue value, what we're going to do is we're going to have 3 different. One for the red, one for the green, and one for the blue. And it kind of looks like 0.393, 769, 189, 349, 686, 168, and 0.272, 0.534, and 0.131. Now we could just do this with simple 3 dot products. You know, if we wanted to do that, that would be okay, and it would make it look just like our grayscale. But instead, what we're going to do is we're going to create a much cleaner solution. What we're going to do is we're going to take those 3 vector values and we're going to collapse them together into a one matrix. So here on this first column is the red column, red sepia. This middle column is the green sepia, and this far column on the right is the blue sepia. And so we're going to take that and we're going to push that into our technique again. Okay, let me go ahead and pull up our shader tool. And once again, let's drop that in here and pull in our sepia pixel shader. Okay, we've got the sepia picture, and now here is our 3x3 matrix. Yes, there we go. It all lines up. Okay, there it is. Once again, this far left one is the red sepia, this middle one is the green sepia, and this one on the right is a blue sepia. Then we're going to grab our color from our render target, and then all we're going to do is do a matrix multiplication of our color, and we're only going to do a 3x3 matrix this time. So we got to get the color RGB, and then we're going to multiply it by our sepia filter. And then we're just going to slap the alpha right on top of it. So really, that's all that there is to it. We just multiply all 3 of those things by one matrix operation. Yep, that's all that it takes, gang. And so let me go ahead and add a new sepia filter technique. All right, so we've got that going. So I'm going to change my technique over to my sepia filter. And there we go. There is my sepia tone filter, and you'll see that it is looking kind of black and white, but it's looking kind of old-fashioned and look a little bit reddish, a little bit brownish. All right, so that is really all that there is to it. So there's not, you know, not a whole lot there, and so that's what makes some of these fun. But the technique that we used for generating the sepia tone, that can be extrapolated one step further. And if you really think about it, then if you do it right, then you realize that you can take any of these techniques, the grayscale, the inverse, or the sepia, and then you can convert those into matrices. And that's exactly what we're going to do. A grayscale one would be where you've got the red, the green, and the blue. And then remember how we did RRR for the grayscale? Well, that means that we're just going to duplicate all the same for the red, the green, and the blue with the exact same, we're going to do it all for the exact same vector. All right, now for the inverse, it's a little simpler. All we have to do is multiply the red, the green, and the blue color by -1, and that's all that we need. So we're just going to create a matrix with -1s going across the diagonal. And then here's our sepia tone filter, which is our exact same. Okay, so let's go ahead and see if we can manipulate this inside of our shader tool. All right, I'm going to add this one more time. Now for this, what I'm going to need is one new piece of resource, and that is I'm going to need a C buffer per frame, and then I'm going to need my color buffer. I'm going to need this to come from an external source, and so I'm going to look for a 4x4 color filter, and this is going to be what our 4x4 filter is. All right, and so this is going to get super simple, gang. Take a look at this. So our generic pixel shader, it's going to be a variation of our sepia pixel shader. And there it is. We're just going to input our render target, and then we're going to multiply it whatever the color filter is. And that's all there is to it, gang. Not a whole lot there. And I'm going to create one more generic, I'm going to have one more technique. And this will be the last technique that we need, because as you will see, all we need are the matrix values in order to create our visual effect. And you'll see that, hey, it says, okay, we've got this here now, and we've got a color filter, and we're looking for a 4x4. And I'm going to change this over to generic filter, and you'll see that it's just red, green, and blue, just looking normal. But if we want it to look like a black and white image, then I'm going to plug in my black and white matrix, plug this into the filter, and voila, instant black and white. And now if I wanted to look at inverse, I'm just going to grab my inverse filter, plug that one in, and there's my inverse filter. And of course, as you would expect, here we go, we want the sepia, and we just plug our sepia in, and then we have our sepia tone. And so that's all that is, folks. When you go and look at the color manipulation inside any of these engines, that's all they're really doing, is they're just modifying this one custom matrix depending on the values of the red, green, and blue, and bringing them up or lowering them down. And this is all controlled by the same. Now you're saying, okay, well, that's all good and fine, but man, I'm a visual effects artist. I want some fast action, and this has got to be an engine. Okay, cool. So let's go inside of engine. I have something set up, and we are ready to rock and roll. Okay, I'm going to pull up UE5 here. All right, so here we have is a groovy scene that's ready to be placed in here and ready to rock and roll here. And so I'm going to go ahead and drop into here. I've got my own little level, and then I'm going to go and create a new material. And this new material is, oh yeah, here we go, material. Okay, I'm going to call this PP for post-process, and I'm going to call it custom matrix demo. All right. Okay, bring that over here. Okay, here we go, folks. Now, because we're going to be doing this for a post-process, we're going to have to do some kind of fancy things. So what we're going to have to do is modify our shading for our, and we're going to have to change this into unlit material. Why? It's because we're not actually using lighting for any of this. We are just performing math on the operation. So we're going to change the material domain. We're going to change that to a post-process, and it's going to go immediately black. And you'll notice that everything kind of goes away. And so therefore our shading model can therefore go to unlit because, you know, we don't have anything lit in here. Okay, then what we have to do is we want to bring in our custom node here. So I'm going to type in custom. Yep, that's all that there is, folks. And here is our custom node. If you've never worked with custom nodes, they're a little bit awkward to work with, but once you get past the awkwardness, then they're actually going to be kind of useful. Now, we're not going to go too deep into really generating the custom nodes this week, but stay tuned for next week and the following, because we're really going to go into deep, because there's really, once you understand how to manipulate them, they're really pretty powerful, and they're really, really groovy things. All right, so as far as the description, I'm going to call this, what do we call this guy? Our description, we're going to call it post-process matrix. All right, and let's see. We want to get, let's see, 4 inputs. And so we can control our inputs by opening up the thing and then making sure that we have 4 input members. We want 1, 2, 3, 4, and let's see. We want the first one to be our scene texture, which is a fancy way of saying, all right, bud, give us our render target. Yeah, that's fancy. That's all that means. Is like, give us the render target. And then here we want is the value for our red vector. So we're going to call this red. All right, I'm going to make the second one green. And we're going to make the third one blue. Now, I'm just calling them red, green, and blue because really what they correspond to is the first, second, and third vectors. But that's all that we really need for this. Okay, and then as far as the code is concerned, I'm just going to paste the code right in here. And the code is really, really simple. It's a little bit small, it's a little bit dinky, but what I have here is a float 3x3 color filter equals color 1, color 2, and then color 3. Okay, so that's what's coming in, and that's what's going to be our color filter. And then, okay, because we're bringing it in, one color, and then the other color, and the other color, we're kind of stacking them. And then what we have to do is, because they're stacked, what we need to do is take that whole matrix and put it on its side. So that's called a transposition, and then we're going to be transposing our matrix. Then all we're going to do is we're going to take the color from our scene texture, and then we're going to multiply it by our color filter, and voila, that's all we're going to have. So we're just going to do a simple matrix multiplication, and that's all we're going to have here. All right, I'm going to plug that in here. So we still don't have any of the data, so it says, hey, I don't have any of the information I need, so why don't you give that to me? Okay, so let's go ahead and get our render target, and our render target comes from something called a scene texture. Here we go, scene texture, and we don't want the scene color. We want the render target, and that is stored here in post-process input 0, and there's our color. And if we go ahead and plug that right into there, boom, boom, boom. Do we have values in here? No, we do not. So let's go ahead and get vectors for our red, green, and blue vectors. And so I'm going to just grab a color parameter, or we want this is a vector parameter. We have a vector parameter, and then I'm going to call this red. And for giggles, just to make sure that it is the red, I'm going to give it a red color. Not that I really need it to be red, but I'm just kind of making sure that we have visual consistency. So I'm going to plug that into the red channel. Oh, before we got the red channel, before we do that, remember, the input is coming in as a 3x3 color. That means that there is no alpha value. So what we have to do is mask that out. So I'm going to mask out my, grab my component mask, and I'm going to mask out my alpha. And so I'm going to click, I want the red, green, and the blue, and then I'm going to plug that in. All right, so we've got those two here. And so for the other two channels, I'm just going to duplicate these. There's that. and duplicate it one more time. There we go. Okay, I'm going to call this one green. Grebe. No, we want green. Okay. Now let's make this one blue. All right, now let's, for visual consistency, let's just go ahead and make this one green. And so that one is 0 there, 1 in the green. Okay, and then let's make this blue. Okay. Let's make this 0, and then the blue value of 1. All right, so what we're going to do is plug that into the green value, and then the blue. And so, okay, this should actually start to click on here. Undeclared identifier color 1. Okay, we got our color, our UVs. And we got our mask RGB, ask RGB. Okay, color 1. Oh, look at me, folks. I goofed. Look at that. I called these color 1, color 2, color 3, but I changed these by the input names incorrectly. So I'm just going to call this one, let's see, should be color 1. This one should be called color 2. And this one should be called color 3. Okay, comma express here, the scene texture. Comma expression is used where a vector constructor may have been intended. Warning, potentially unintended use of comma. Warning, warning, warning. Error, cannot explicitly convert constant 3 to a row major float 3 by 3. Why not? So if I put a comment here, will it understand this? Okay, well, this isn't fun. Well, what I'm going to do is I'm going to copy, I did this ahead of time before, and I'm going to copy my other one that I used over there. So I'm going to go over here, and I'm going to go for my, I'm looking for my materials. Ooh, look at all that. Look at all those materials. Too many. Okay, in camera, materials. Okay, here we go. This is all a preview of what we're going to be seeing next week. Ooh, look at all those. And then we're going to go on my mats. Let's take a look at that. Is it in there? Nope. And then our TATL, the starter content, environment custom shaders, materials. Okay, PPD saturate. Okay, generic matrix. Here we go. Oh, that's what it's going to end up being. So that's not what I wanted though. PP generic matrix. There we go. And so I don't know what the deal on that, folks, was, but there it is. We have the PP generic matrix. And there it is, same exact darn shader, but it decided to start misbehaving on me. Well, this is Ticker Talk Live. We've got to mess up once. Okay, cool. So we've got this custom, this generic matrix here. So let's go ahead and make a material instance out of this. So I'm going to right click on here. No, I say right click on here, create material instance, and I'm going to call this MI. Oh, what did I call this? This is called generic matrix demo. Okay. Okay, there it is. There's our new generic matrix demo. So let's go ahead and toss this into the scene here. All right, so we have to look up what our post process is. We're going to look up post process my post-process volume, and then I'm going to come all the way down to here, and where it says white balance. No, it's not past theirs. Is it the film? No, 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 no. Reflections, rendering. Okay, post-process materials. All right, this is what we want. I'm going to add this, and I'm going to choose a asset reference, and then I am going to choose a generic matrix demo. There we go. Okay, now notice that nothing really changes on here. Why? Is that because we have our red value is 1, the green value is 1, and the blue value is 1. So nothing's really changed, but let's actually go ahead and look at that generically and interactively. Okay, so there is our red, green, and blue vectors. So what I'm going to do is interactively, I'm going to update them. So let's just say that I wanted it to be grayscale. And so that means if I take this red value and then I make it, let's say, 0.299, and then I want the green value to 0.587, and this would be 0.144. Okay, so we've got that for the red. So let's do that again for the green, and that's 0.299, 0.587, and then 0.144. Okay, you can see it's starting to desaturate right there. And let's go ahead and click that in there. And so let's make the blue the same thing as 0.299, 0.587, and 0.144. Oh, come on, 0.144. Let's kill our blue. Okay, there it is, folks. There is our same kind of like halftone, or the same grayscale image that we were working on before. If we wanted to go ahead and do this to change this into sepia tone, we would just change these values into the sepia tone values. Let's go ahead and do that right now. So this red value is 0.393 and 0.769, and then 0.189. Okay, that's our red channel. And our green channel is going to look somewhat similar to that, but still not there. 0.349, and then 0.686, and then 0.168. Okay, so we were really starting to see it desaturating now, but it's going to start to veer over to the kind of like reddish browns here. So we're going to go 0.272, and then 0.535 or 0.534. And 0.131. Okay, there we go. There's our sepia tone for our image. So you see that now once we have these vectors controlled, we can create any kind of brand new matrix that we want. We can take the red value and we can maneuver these back and forth in order to change our color values around, and we can manipulate these to whatever we want to be. And so this is what's going on inside Photoshop. This is what's going inside your color correction inside of your game engine. And so that's really all that's going on here. This, my friends, is one of the most powerful visual effects you can possibly have. You can change the color of your entire environment just by a few slight channels, and it's one of the world's easiest effects. And so that's why it's just so much fun to play with and so easy to work with. All right, so that's what I wanted to show you today. But next week, okay, hold on to your hats, folks. Now, next week, that's going to be the 8th of October at 12:30, we're going to go into convolution filters. Now, convolution filters are really super powerful, and then this is where you're going to get all your blur. This is where you're going to get all your image distortion. This is where you're going to get all of your change in value. And this is really, really important when you're creating things like motion blur. This is where you're going to get your bloom. This is where you're going to get your depth of field. It's all going to come from this, the creation of the convolution filter, or the convolution matrix. And so that's what we're going to be looking at next week. Okay, now if you enjoyed what you're looking at today, go ahead and subscribe to this channel by clicking on the little button over on the right-hand corner. Subscribe to us on YouTube, or my name is Chris Rhoda. You can subscribe to me on Facebook or on LinkedIn, or you can go check out Art EDU, which is also on Facebook and on LinkedIn. And so therefore, go check us out at Art EDU. Okay, we're all done writing their visual effects book. More information on this in the times come, but guess what? Real-time visual effects for the real-time visual effects for the technical artist is just about finished, gang. It's at the publisher. It's in their hot little hands right now. They're doing their magic on it, and hopefully we'll have this book out sometime too. All right, but anyway, if you want to check out what's all going on with everything going on here at Art EDU, go check us out, the techartedu.com website. And if you want to, go ahead and click into, there's a little opt-in button. Go ahead and opt in, leave us your name and your email address, and we'll make sure that if we ever actually do get to announcements and newsletters, we'll make sure that you get one. All right, folks, thank you very much for your time today. I enjoyed appreciating all about this stuff going into post-processing. And I look forward to bringing you more information about convolution filters next week. And until then, arrivederci.